Next up, we look at two commands, more and less. And those are both commands that work sort of like the page command, and they're both better than page, I believe. You may like page, but I like less, actually, quite a bit better than the other two. Okay, so the more pager can be used to browse or page through a text file. It displays the word more and a percent of the percent of the characters displayed so far at the bottom of the screen, and we saw that the last time. For continuity, the more provides about 2 lines of overlap between screens. That is, it shows you when it shows you the first page and then you hit space to go on to the next page, it shows you that last line, plus it shows you a whole bunch of characters, and then shows you, the very last line, which it'll show you again when you go to the next page. Okay, so we just took a quick look at that before we say more.bashrc. It shows you more, the percent of characters. Now if I hit return, I just get everything just moves up 1 line. But if I hit space, actually it looks like it didn't even display that last line, unlike what the book says. Okay, so looks like it just omits that last line, doesn't show you much overlap, and the way more works here. Okay, so slight correction with what the book says. It doesn't actually provide 2 lines of overlap. So the options that you have are space to move the cursor ahead 1 screen or 1 page, return to have the entire file scroll 1 line, or Q to completely exit the more command. Okay, and then there are other options like show just the first 10 lines per screen, or 100 lines, or start at 100 lines, and so on. You can also search for certain things, and you can do that even if you don't use the command line option. So if you have, let's say you're over here and you want to search, you hit the /THEN. I know this is something that does exist in this file. Hit enter, and I think it did find it, but it's not obvious that it found it. So I can hit N again, N to search again, and it actually doesn't find anything. So let's try that again, more.bashrc, and this time we'll search for something that we know exists more than once. So for example, uppercase IF. I know I see that over here and over here. IF. I think the search is case sensitive, I believe. Okay, so it finds it over here, I believe. Okay, that's odd. It is. I think it is working. It's just not working the way I expect it to work. Let's try searching for lowercase if. There is one. If I say N, there is another one. This looks okay. It's not obvious that it's pointing out what it finds. That's what I'm worried about as I look at the output of this more command. So it is actually working. It's just not very user-friendly to me. Okay, so you can search. You can skip lines. There's a whole bunch of commands that you can try. And you can press H to obtain a list of available options. It's not a lot of options that people use with more. It's usually just space, return, or Q. It's usually all you do. Okay, Linux comes with its own page command, which is less. So the opposite of more idea is that less is more. Okay, so less is yet another pager that's provided under Linux. It's similar to more, but it also allows backward movement in the file as well as forward movement. Actually, to tell you the truth, more now allows backward movement. It didn't at first. More only allowed you In the past, more only allowed you to go forward. Then people came up with less, and then the people who wrote more changed it so that it can do the same thing as less. So now we're back to more and less being basically the same. I don't know exactly what the differences are. There might not be any differences at all at this point. Okay. The last topic in this chapter is this idea of inode numbers. This is how the Unix file system keeps track of files. And let me start with an example. Rather than going through and explaining exactly what inodes are, let's take the example of copy and link. Okay, so let me clear this. I have a directory called let me see what's in here. Okay, that's fine. So if I say ls-l, I see that. Now here's the thing. You can find out low-level ways that Linux identifies files. How do you do that? You say ls space -i. And let's try to make it il. Okay, so when I say I and l, I see the inode numbers along with the long listing of each file. Note that these numbers are all different. What will happen if I say make copy of phones? So I'll copy phones and I'll call it phone list. Alright, and I'll do the same thing as before, ls space -il. And notice that I get both phones and phone list, and the inode numbers, that is the number of the file in this entire Unix file system, is different. However, if I say ln phones, and then I'll call it shortcut, because that's what it really is. Okay, so now here's the difference with copy. ls-li. Notice phones and phone list have different inode numbers, but phones has the same inode number as shortcut. That's because shortcut is just another name for phones. Remember, with ln, what you're making is a link. That is, shortcut is a link, just a shortcut to the phones file. And we saw that if you edit phones, phone list doesn't change, but shortcut will. So you can try that. You can append something to the end of, oops, I'd use two greater thans. Name tab followed by phone number tab by email. Okay, and I hit Control D, and so watch this. I changed the phones file, but if I do an ls-li, notice phones changed in size from 172 to 217. Phone list did not change because it is a physical copy of what phones used to be, so phones was copied. At this point they're all three the same size because phone list was just a copy, a physical copy. Shortcut is just a shortcut to the phones file, and so it has the same size. If you change phones, phone list does not change, shortcut does. So once again, if you have a shortcut, you change one, the other one changes too, because this is just a shortcut to the same file. And you can see that over here, they have the same inode number. Okay, so with that in mind, let's take a look at the notes on inode numbers. So this is details about the file system. The Unix file system associates every file name with a number called its inode number and identifies each file by its inode number. That's how it keeps everything separate. Unix keeps all these inode numbers in a list. It's called an inode list. This is on every disk drive or hard drive. This list is saved on the Unix disk. So the Unix disk or file system has a certain structure. A disk is a standard block device, and a Unix disk is divided into 4 blocks or regions. There's first a boot block, which allows you to boot off that disk. There's a super block. There's an inode list block, and then the actual files and folders that are files and directories that are stored on that drive. The boot block contains the boot program that's used to start up the system. The super block contains information about the disk itself, how many disk blocks it has, the size of each block, the number of free blocks, and the number of used blocks. The iList block is a table of inodes. So it's a table. Each entry in this list is an inode that is a 64-byte storage area, and that changes actually with different file systems. I believe this is still good. It's a 64-byte storage area, I believe. The inode of a regular file or directory contains the location of its disk block. So it just tells you where in that disk to find all the different parts of the file. The inode of a special file contains information that identifies a peripheral device. So these are device files and things like that. So inodes also contain other information such as the permission. Remember, if you say an ls-l, you see file permission. All of that is stored in the inode. Then you see the owner and group ID, the file link count. Remember the link count that appears when you say ls-l. Time of the last modification, last access. All of these things that you get with ls-l is stored in the inode. Inodes are numbered sequentially, so if you create a file, you create a copy of a file, chances are it'll be the next number. Okay. Inode 2 contains the location of the blocks that contain the root directory. So there's inode, I don't know if there's an inode 1. There probably is, but inode 2, and if you remember, we're up to 36,000, inode number 36,478. So if you go back to the very first thing that was created, I'm not sure exactly what that is, but number 2 will contain the location of the root directory. A Unix directory contains a list of file names and their associated inode numbers. So that's actually all a directory is. It is actually just a file, but it's a special file containing all the file names and their inode numbers. That's all it is. That's all a directory is. It's not actually some magical container that holds different files. No, it's just a file with file names and inode numbers. Okay, so now that you know this, I'll take a look at this explanation about inode numbers in this chapter 8 towards the very end. It shows you exactly shows you pictorially what, for example, a directory is, and looks at inode numbers and things like that. And we just did this. We said ls minus I, and you can combine that with ls minus il, shows you even more information. So try out this, try out ls minus I in your home directory, try to make files, try to make links, try to make copies, try and see what happens. And move things around, just like it's like was done in this one last example of this book. Okay.